Hello, my name is Bryce Cooper, and in this video I will be explaining conservation of energy. In order to explain this topic, I'll be using a pendulum simulation on PhET. The basic concept of conservation of energy is that in ideal conditions, mechanical energy is always the total energy in the system. It can also be shown as potential energy plus kinetic energy. Potential energy is the energy that gets stored within an object and gives it the potential to move. As you can see, when I lift the pendulum to the top of its swing, it gets a large amount of potential energy. Kinetic energy is when the potential energy gets converted into motion, which is why kinetic energy is a combination of mass and velocity, which, as you can see, when it hits the bottom of its swing, kinetic energy is at the maximum that potential energy was originally at. These concepts of mechanical energy, kinetic energy, and potential energy are used in tandem in physics and are manipulated to make the equations maximum kinetic energy equals maximum potential energy, and kinetic energy plus potential energy equals mechanical energy. However, these concepts are only true in ideal conditions, and in the real world, objects are not usually moving under ideal conditions like these. So I will show what happens when an object is not in ideal conditions by increasing the friction on this object. And as you can see, E thermal, over on the energy graph, continues to increase, while the maximum kinetic energy and potential energy continue to decrease, therefore lessening the amplitude of the swing. These are my two problems on conservation of energy. Problem 1, Part A. A pendulum is swinging back and forth with a maximum height of 10 meters. The mass of the pendulum is 15 kilograms. What is the kinetic energy of the pendulum at the maximum height? Assume friction is negligible. The answers are A, 1500 joules, B, 0 joules, C, 150 joules, or D, 1000 joules. The answer is B because the equations for potential energy and kinetic energy are mgh and 1/2 mv squared respectively, which means that since potential energy is at a maximum, kinetic energy must be 0. What is the potential energy of the pendulum at the bottom of its swing? The answers are A, 0 joules, B, 100 joules, C, 1500 joules, or D, 150 joules. The answer is C because at the bottom of the swing, kinetic energy is at its maximum, so we should find the maximum gravitational potential energy, and then the equation kinetic energy max and potential energy max shows that should be the answer. The maximum gravitational potential energy is found by using mgh, which in this case would be 15 times 10 times 10, which is 1500 joules. And then problem 2, the pendulum now has friction applied to it. After several swings back and forth, what will happen to the maximum gravitational potential energy? It will decrease because if the pendulum has friction applied to it, then the system can no longer conserve energy, as it is being turned into heat, so the maximum gravitational potential energy and maximum kinetic energy will both decrease.